Hello, everyone, and welcome to Demo Days. Happy Friday to you all. Nice to see you. Happy Saturday to those who are staying up late. It's awesome to see everyone from UAE, Kurdistan, Minnesota, Turkey, Chile. We've got a nice worldwide audience today and a very exciting Demo Days. Today, we have the next piece in our discussion of infrastructure as code. We started off by talking about infrastructure as code from first principles, and then Jürgen took us through how GitHub uses ISC to deploy. And today, we're going to get even more specific and talk about security automation. So, if you find this demo day useful and want to talk about it in your company's specific context, please feel free to use the QR code in the corner and book a meeting with us. So today, I'm going to introduce you all to Andrew Weiss, a Field Solutions Engineer at GitHub, and our special guests for today, Aaron Lippold and Robert Clark from MITRE, who will be talking about security and compliance automation. Andrew?
Hey, thanks so much, AJ. Thank you all for joining today. So as AJ said, this is really a continuation in our series on infrastructure as code. And today we really want to dive in and take a closer look at how we can apply security approaches and best practices to our infrastructure. And I'm really excited today to have both Robert and Aaron here as guests of ours with MITRE, and I'll let them introduce themselves here in a second. But MITRE is a nonprofit research group focused on cybersecurity research. And you're going to hear more today about this really awesome framework that they've been developing, and that's used across a lot of different entities and corporations around the world today. It's really all about how we can apply these infrastructure as code principles and apply them to automation at scale. And so Aaron and Robert are going to take a really nice look at this automation framework, this SAFe framework, and talk about how you can harden infrastructure and combine those infrastructure as code resources with some of the best practices that we see across industry today. So without further ado, Robert, Aaron, you guys want to introduce yourselves to the audience here today?
Yep. Hello, I'm Robert Clark. I'm one of the lead developers on the MITRE SAFe team. And Aaron?
Hi, I'm Aaron Lippold. I am the lead and architect of the SAF and one of the primary creators of the SAF.
Awesome. Thanks so much, gentlemen. So this SAF that we're talking about here, this security automation framework in short, and I think, Robert, you have some information about this that you want to share for the audience today. I've heard a little bit about this. I've heard some individuals that I work with. I do a lot of work in the security community as well, and they talked about this framework before. And I myself have dabbled in security automation tools. I think there's this awesome open source project out there like Inspect from the Chef community and some other automation tools. Could you describe a little bit more about this framework, what it is specifically? I'm on your website here, saf.mitre.org. But Robert, if you want to give us a quick little intro about this framework and some of the backing behind it.
Sure. So security automation framework, what basically is really a collection of tools and techniques that we've put together to basically make it easier to automate and to, both the deployment and validation of your security posture. So in order to do this, we utilize a bunch of open source tools that are out there, such as you mentioned, Inspect. We utilize Chef, we utilize Ansible, we utilize Puppet. We're not trying to reinvent the wheel here. We're just trying to bring them all together and show how all those can be put together and used to have a strong security posture. And so we actually also use GitHub Actions and a lot of tools from GitHub to actually automate this and kind of, well, make our development lives easier as the people developing this framework. And so at this point, Andrew, if you want me to dive in, I can talk a little bit more specifically on the pillars of what SAF is, if you'd like.
We've talked about previously on our channel here, mentioned Terraform and Chef, and it sounds like this framework is totally tooling agnostic. Really, it's more of kind of an overlay, regardless of the tools you want to use. Of course, it's standards based, based on the site here. But if you could talk a little bit more about the framework, provide us kind of an end-to-end, framework lifecycle here. I think you've got some content too on kind of the different phases of the SAF and how the tools fit into that.
Absolutely, yeah. So there's 4 main pillars to the security automation framework. We've got hardening, validation, normalization, and visualization. So in order to validate content, what we do is we utilize the Chef Inspect we utilize Chef Inspect. Chef Inspect is a compliance as code, a domain-specific language. So we write all of our hardening in Inspect. The thing is, when we're writing hardening content, we need to actually be able to take it and test it. So, when we're writing validation content, we need to actually be able to test against something. So what we also have to do is the first pillar of the SAF, which is actually harden things. So we have a collection of different hardening profiles that we've written, either we've written or others in the community have written. And we take these and then we run them against a box, and then we go ahead and run our validation scripts as well. And those validation scripts, in the case of, for example, the example I have here is the Red Hat Red Hat 7 STIG baseline. In the case of these scripts, we actually go ahead and use GitHub Actions to make sure that any changes that we make to these profiles or any changes that the community proposes to these profiles are actually up to the standards that we'd expect for when we redistribute these.
And could you talk more for folks that may be unfamiliar with just general hardening techniques from an infrastructure perspective? What exactly are these profiles doing to the operating system here? You know, I imagine that they're locking certain aspects of the operating system down or configuring in such a way that it meets these requirements. Where do these requirements come from? And what are some of the common things that are being locked down, you know, when these profiles are applied?
Of course. So Aaron, do you actually want to take that one? You have been doing this you've been doing the hardening side of things for a long time. So you probably have a great example off the top of your head.
May have some connectivity issues with Aaron while we're dealing with that. Robert, you want to maybe take that to start?
Of course, yeah. I mean, I can do it too. Not a problem.
Sure.
So there's a lot of this content. A lot of this content is coming from the a lot of the content that we work at least comes from STIGs, right? So Security Technical Implementation Guides. These are published by DISA, and basically some of the examples of these controls could just be something as simple as you have to lock your screen automatically when you step away, right? That's just, you know, one simple example. They get a lot more complicated than that, but that's something that probably everyone can grasp pretty easily. And so, I apologize. Could you actually repeat the question? I was
going to say, so basically you have these guidelines, you know, whether for, you know, government communities or other regulated industry, because we have some folks, you know, from around the world here. So maybe you're working with different regulatory standards like ISO or healthcare compliance, and basically they define all these control requirements, and you map those and you turn those into these as code, quote unquote, specifications, right? So you take that security guide and you apply them as specifications. And that's what I'm looking at here, right? These profile baselines.
Correct. Yeah, these profile baselines are taking, in this example, right, it's a STIG baseline. So that's based off the DISA Security Technical Implementation Guide, right? And we go ahead and map those, yes, basically we rewrite these into inspect code instead of, so they provide so for example, the STIG generally provides an example of, oh, this is what you need to check, right? Well, we actually take that check and we make it an automated check so that you're not just doing that by hand when you're trying to validate that a system is actually compliant. And some of these, so we also have some for other standards, such as we have some CIS benchmarks, for example, is another large standards body. Those are kind of the two main ones that we deal with here. That's not to say that InspecTools is locked into either of those standards bodies. Those just happen to be the two that we mainly work with, working for government sponsors.
Hey, Robert,
Awesome.
Do you want to actually hop over to the validation page rather than the hardening page?
Of course.
There we go. So that's what we're talking about. Sorry about that. For some reason, my laptop went crazy, so I'm on my phone. So I apologize for the shaky video for a few seconds here. But so at the high level, right, we wanted to make sure that we were able to easily translate a lot of these security requirements into automatable, integratable components that you could put into your pipelines and put as part of your ongoing business process, be that the first day of development or the 100th day of development. And this isn't limited to just standards, right? On top of these baselines that you might have to validate for your components, right? I'm going to deploy a system that meets CIS standards or STIG standards. You could also write these security profiles using these the same compliance framework to say, well, my organization has defined some standards, or the application that I'm building has a set of ports, protocols, users, applications, packages. And I could align those to the relevant security controls, like the fact that I'm managing my users at my application level, right, manages part of my AC controls, my access control requirements as part of the NIST, or CIS's access control requirement. And you could tag those tests for the functional and unit tests in your application. So the one realization that we try to help teams have is that security testing is really just specialized functional and unit testing, right? My application has to function in the deployment context where I'm going to deploy it, and this rules of engagement that we need to be able to meet, right? The developed application is all wonderful and all of its application capabilities are great, right? Innovation, right? But I can't bring that innovation to bear unless I can pass it through the gates of security and the operators that are responsible for maintaining all your networks, right? You have to play with that part of the community as well. And this gives you a mechanism to communicate that you did what they need you to do so they can be supportive of making you successful.
Gotcha. Yeah, that makes total sense. So it sounds like validation it's kind of an attestation as code mechanism for all different teams, because, you made a good point. It's not just the developers writing software day to day. It's all about the operations personnel that are operating this infrastructure, writing these infrastructure as code artifacts, the security, compliance, and risk teams that are ensuring that the deployment or the declarative deployment is as what we wanted it to be. And of course, we can attest to that. So with that being said, Robert, can you maybe go through like an end-to-end flow with the SAF? You give us some sneak peek on how to use or how you're using GitHub, but I guess what's a common workflow that you all employ with the SAF framework and how you use GitHub, or highlight how you use GitHub more for that?
Sure. So a lot of the times, so a lot of this existing CI tools kind of have very similar functionality, right? But there's kind of two things that, or one main thing that really stands out about GitHub Actions, and it's the reason that we actually use it for a lot of our end-to-end testing of profiles. I'm going to go back to the example I had up before, the Red Hat Enterprise 7 STIG baseline. This profile, when we're doing, basically when we're doing development and testing on it, one of the important things for us is that we can actually stand up a clean box and actually make sure that when we harden that box and when we validate against that box, that it is basically that, it's not just some system that we've been messing with and doing manual changes on, it's fully automated. And so it's one of the things we like so much about actually using GitHub workflows and GitHub Actions for this, is we can actually take a GitHub Actions Mac runner and actually run Vagrant on it, Vagrant being a tool that actually deploys VMs. And we can actually stand up a hardened and a vanilla VM and then go ahead and use some of our other tools to actually test and make sure that that VM meets our compliance threshold, make sure that we didn't introduce any new errors into our inspect profile that we wrote as part of our development. And I would love to do a deep dive on that if that's interesting, Andrew. I'd be happy to talk through a little bit more of how this workflow works, if that's something.
Yeah, could you maybe go into that? Because it's really cool that you're using GitHub Actions, which has its own infrastructure, and then you're deploying other infrastructure with Vagrant, and that infrastructure is really representative of your production infrastructure that has to be secured and has to be tested to. Yeah, please do dive deeper into kind of what workflows you're using and how you've crafted these actions.
Okay, awesome.
Well, I mean, the one thing that I do want to point out is, Andrew, we're actually doing something even more geeky than that. We're actually using Test Kitchen to talk to various Vagrant or EC2, Amazon, AWS, the CLI, right, to deploy infrastructure on Amazon, or to deploy it on Vagrant, or to deploy it on Docker, right? So we've got like 3 levels of abstraction all built in here, such that I can replicate this workflow process locally through Kitchen via Vagrant, or I can do it remotely on a cloud instance, right? I can go call out to EC2 and say, I also want you to replicate the same workflow on an EC2 box in AWS. Oh, and I also want you to do it on a Docker container running on a Docker swarm somewhere, right? So I'm shifting the context of my deployment location and modifying my testing all in an automated, continuous fashion. So if I say I'm supporting local boxes, cloud instances, Docker containers, right? I can replicate that whole ecosystem in this workflow using the GitHub Actions test kitchen and some of the technologies, bringing all these pieces together.
That's really cool.
Such that
And
everybody
so
on my team.
I was going to say, and Test Kitchen is it's a tool from Chef, right, for automating certain infrastructure tasks. I guess maybe Robert was going to go into that, but just for folks on dialed in today.
Yes,
Yep,
there's
absolutely.
a couple
something
layers.
Originally.
Sorry, Aaron, I'll let you finish. I apologize.
No, it's I'm in El Salvador, so it's just a little bit of lag. I'm sorry. Yeah, the Test Kitchen was originally developed to test containers, or I'm sorry, recipes, chef recipes. But we kind of took the capability and said, you know what, I could do a heck of a lot more with this. So we completely bent it on its side and said, we're going to really use this to be our orchestration platform that we can hold in code, right? And then I'm using your orchestration platform to execute my orchestration platform to do all this testing. So anyway, I'll let Robert go from there.
All right, thanks, Aaron. Yeah, so yes, we're using Test Kitchen at one layer. Test Kitchen is actually a wrapper around Vagrant, which is another tool, that one's by HashiCorp, that basically orchestrates virtual machines. And then from there, we can execute commands as part of the kitchen scripts to actually run inspec as well. It's actually pretty natively integrated since Chef builds both inspec and Test Kitchen. And so this is kind of the overall workflow, and the same Test Kitchen actually is, I guess, runner runner agnostic in a sense. It doesn't care if it's got Vagrant or EC2 or Docker under it. It's got executors for all of those. So this is kind of the overview. Diving into the actual code, where I'm most comfortable, right, is basically what we do is we go ahead and set up a test matrix, a vanilla and a hardened test matrix. And then in this case, this is the Vagrant executor, but we set up the vanilla and hardened test matrix. Then we go ahead and use kitchen with just one command to go ahead and deploy either the hardened or vanilla. We tell it basically to deploy either the hardened or vanilla matrix, and then we go ahead and use a tool that we build called InspecTools. InspecTools is actually useful for, has a couple useful things built into it for validating that you're actually compliant to a specific level. Either compliance or summary are the two tools we're going to be using here. And I'll talk a little bit more about why that's necessary in a second. But we go ahead and actually use that to go ahead and check whether we meet the either the vanilla or hardened threshold. The threshold files are quite simple. They're just a thing, a file that says how many errors am I allowed to have in this profile run? Well, we're the developers. We don't want there to be any errors, right? That means that the test actually failed to execute. We don't want any of those in either the vanilla or the hardened profile. And the vanilla profile, we don't really care about compliance because it's just an unhardened box. Of course, it's not going to be compliant. And then the other one is our hardened profile. We want that to at least be up to 80% compliant and have no errors as well during its run.
Gotcha. So something I want to highlight here, and you bring up a good point, is like when you're doing security and compliance, there's no way to be 100% risk-free. There's always a little bit of risk you have to assume. So there is a little bit of a buffer in your threshold. Things are going to break. Certain things may potentially be vulnerable there. So it's all about assuming acceptable level of risk for the organization, pursuant to your regulatory requirements. Again, it's not just U.S. federal, U.S. regulatory requirements, maybe international requirements. So some interesting tactics that you all are taking there, in order to set those thresholds, because it's all about conveying that risk to those organizations.
Absolutely, yeah. And sorry, Aaron, go ahead. The delay is getting.
And if you take a look at some of the patterns that we built into the inspec language, so the inspec language was built in partnership between Deutsche Telekom, Chef, and MITRE. So we're actually one of the original partners that developed this. And some of the things that we built in were the ability to do dependency chaining in your security validation profiles so that you could articulate those accepted risk changes in your profile. So I know I can't pass 5 out of the 500 tests, right? And instead of those failing all the time and basically generating noise, being false fails, if I have accounted for that you can do an overlay to basically put in a justification and say, I'm going to set the impact of this to 0. It's not applicable. Here is the caveat or the justification as to why my security team has said it's okay for us to pass or fail this test or whatever. And I've accounted for that. So now it's not noise in your system, right? And then you could even articulate that in your threshold file to say, I expect 80% compliant with 10 items that I've denoted as not applicable, right? And no errors, right? And then if you push up a PR that basically says, oh, I'm able to resolve this now, I'm able to fix it, you remove that non-applicable, right? You just take it out of that pattern, right? And now you have positive control inside your configuration management system of everything that you're accountable for as the development/operations team. So that if your boss comes to you and says, can you deploy tomorrow? You go, well, let's look and see in the last PR build. Yep, last PR build is ready to go, and it's meeting the threshold. We can go right now if you want. Let's push the button, right? Because continuous deployment, right, or ongoing deployment, right, is nice, but in real-world operational systems, right, there's always a decision point that basically says, did I pass all my tests? Is everybody okay with where we're at? All right, now make a decision, right? Because on mission critical systems that are life critical, right, you can't just push right out to production, right? Somebody has to take accountability for that. And this helps you articulate that so they can take that decision down to, yep, all my numbers, we met our agreements, we're good to go. And that's really what we're trying to help the community build as a workflow pattern. You know?
Yeah, Aaron, you bring up some really good points. I mean, it really makes the pull request even that much more powerful in terms of, obviously driving collaboration. But when you talk about, mission critical systems or safety critical systems, building, software for airbags in a car, right? Or any sort of, safety critical systems, this is really an attestation mechanism to really kind of accelerate that, but in such a way that you don't, assume more risk for the organization. So I think you made some good points there. I want to shift gears a little bit too. So, we've got the workflows, but if I'm, operations personnel or compliance personnel, I may not know anything about GitHub Actions, right? I may not be working in GitHub. So, Robert, how do we go from this to kind of the rest of the workflow you described? I saw this tool that you all built in open source, which looks really cool. This Heimdall tool as well. I guess kind of going with the rest of your flow, how does that fit in, and how do you convey some of these compliance requirements and these outputs, visually to these users?
Of course, yeah. That's actually the next thing I was going to talk about. So thank you, Andrew. So the thing about the output of inspect, right, is it comes out in a format that is not really, it's JSON, right? So that's not really human readable for the most part. I mean, it's human readable, but it's not the thing that most humans would prefer to read. Right, so that's the advantage to our InspecTools summary command here. It can actually read in that inspect JSON and actually knows how to use that to, or knows how to read that and translate the threshold file plus that to an actual proper output. But that's really only useful for our CI runs, because our CI runs care about pass fail. Humans need a little bit more data than that, especially if they're doing development. So what we actually also do is, as part of our actions runs, we go ahead and attach, with every PR, we attach an artifact. And that artifact actually contains the JSON output. And that JSON output, if I go ahead and download it, which I actually think I already have downloaded here, can actually be loaded up into a tool that we write called Heimdall. So Heimdall is a visualizer for Heimdall data format, which is what we refer to the output of inspect as. I'm going to go ahead and load up that vanilla and hardened JSON file that came from the run. I believe this run was run a day or two ago, or last week. So you can see in this run, if we look at just one, or actually if we just use our comparison view that we have built in, we can see the difference between what failed in the vanilla version and what actually we fixed in the hardened version. And if I actually go ahead and expand one of these, the powerful thing about Heimdall is it actually lets you go all the way from, this is the test ID. It lets you go all the way from that test ID all the way down to what specific code caused that pass or fail. And also any, like which specific checks passed or failed, and all the details as well about every single thing you could possibly care about this specific test. And so that's actually more for the human and developer side, right? That allows those people to actually figure out, okay, why is this failing? What do I need to do to fix it? So that basically they can go back, fix it, and then on the next run, this would hopefully actually be no longer a failure if it's something that they can fix.
Right. And we don't intend this to be only for the developer. We intend your operators to execute these security profiles, not just the inspect profiles, but all your other security tools, ToonCube, Burp Suite, SonarCube, DOSAP, Nessus, and the static analysis, dynamic analysis, all these things. And that's what the Heimdall tools is there for, is to convert all those other native formats into this normalized HDF format. And then you can start to layer all those different levels of security for your system that you're looking at together into a common view. And you could pass that over to your developer, your security official, right? All they have to do is load the JSONs, look at it in Heimdall, and say, are the red ones okay? Am I comfortable with these red ones? To give you a yes, right? Because that's really what all this is about, right? The high red ones, right? Are we good with that, right? Because all the green ones and all the non-applicables and all the other ones, right? You guys have already agreed to, right? So how do you sort all this down to say, what do we really need to talk about today to get a go, no-go decision, right? And that's what we're trying to do here.
Yep,
So
and that's.
I was going to say too. So you're bringing in static code results too, and I recently saw in the Heimdall repo there's a new integration with the Sarah format, the static analysis interchange format, which is what we integrate with directly in GitHub and GitHub Advanced Security. So you're saying you can combine static code analysis results from really any tool with the compliance scan results from the infrastructure in which those applications are running on with the rest of the system. I mean, I think that's pretty awesome. It's pretty powerful capability. I mean, you get full traceability from the lines of code all the way through the actual runtime infrastructure with full verification checks and so forth. So how does so we talk about infrastructure as code, like how do tools like Terraform kind of fit into that as well? Because I think we're still talking about, one single instance, like one, virtual machine that you've been testing against, but how do you fit in the rest of the infrastructure artifacts into this as well?
Well, one of the other little sub projects that we worked with the chef guys on was called the InspecTools project, which can actually take your Terraform code and read your Terraform state file and automatically generate inspect tests from that, so that you could run that against your infrastructure to at least say, not from a compliance standpoint, right, but the Terraform did what I expected it to do, and you got a yes or a no. Right? And you could even take that data if you wanted to all the way down to your fabric level and say, yep, I got all green on my Terraform, so everything built as I expected it to build. My configuration management hardened it as I expected it to harden it. My code passed the sniff test in terms of linting and static analysis. And when I ran my Selenium or my dynamic analysis stuff, all that, passed or gave me the results that I am comfortable with. And I converted all that to a common data format. I put it in Heimdall. I filtered it out by the bad things, the red things. And I looked it over and go, am I still comfortable with this go to be out in production, to be out to my customer, right? And if I'm not, how do I communicate who needs to fix what? Well, Heimdall makes that pretty easy because it tells you which set of data, right, each of those failed tests is related to. Is this part of the Terraform code? Is this part of the static analysis? Is this part of the compliance stuff, right? You know what teams they are. You could pass those files back to that team member, say, see, you've got some red, go fix it. Go rerun the profile, make it go green, right? And look at it again. You don't even have to interact with me. You can run these two things, convert them, load them into Heimdall, look at it. I want it to go from red to green, right? Then tell me it is. Submit a PR, submit those artifacts as proof, right? Now you have evidence and attestation that is linked all the way back to the open issue, to the PR, the evidence artifacts, and right back to your system of record. So it's a pretty complete workflow, I think.
Yeah, that's pretty awesome. I mean, I think, a lot of organizations, they face a lot of those challenges today to kind of really connect these dots and do this at scale. And there's a lot of paperwork involved and manual processes and oftentimes monotonous tasks. And, I definitely see this as really helping to accelerate that. One quick question for my own personal interest here. So so you integrate with Terraform, and the work that you did sounds like with Chef is pretty cool. How do you all how does that differ with other tools out there? I think we mentioned on a previous demo days like TFSec and Terraform compliance, which are basically behavior-driven development tools that can check the specification. How do you guys interact with those? Or are they kind of complementary? Are you familiar with those tools? And there's a couple of open source projects that I think are pretty popular out there.
So in general, we work through integration efforts as the community at large kind of brings it up and says, I have a lot of data of X format. I'd love to put it into your format to bring it into the ecosystem, right? And that's kind of how we prioritize what we do for integrations. So we don't have everything under the sun. We don't have the solution for everything, but PR's welcome, right? We've had multiple community members say, hey, here is a converter for this because I like your stuff, but we were also running this tool, so it was useful. Here's a converter, right? Because 9 times out of 10, we've got 4 or 5, maybe 2 or 3 actual data formats, right? We have XML, JSON, text file, right? Spreadsheet. That's what we got. And we've got a converter example that does all of those data types and moves it into the HDF format. So we even have working reference examples that people have used. Other examples that the community has contributed to is fixing bugs, in various types of data formats, or even contributions to Heimdall itself, right? So, excuse me. So we're always open to expanding the community, or listening to new ideas. And a lot of times with those other compliance tools and things like that, a lot of times what we try to do is not just take the data that they provide, but also even add some value to that data. So one of the things that we do in a lot of the HDF conversions is tag it with the 853 control that normally those vendors don't actually align to. But those 853 controls are usually the foundation for every compliance thing that you might do, be it FSMA, be it PCI, be it NIST, be it STIG, DoD, even back to CIS, right? Aligning it back to that compliance foundation actually makes all those tests that are normally just developer noise into an actual business metric that you can build into the workflow. So
yeah, and that's super important. I mean, business metrics at the end of the day are going to be critical to the success of a particular project, and obviously a direct impact on financials and so forth. So I think that's super helpful. Robert, I want to go back to you too, because I think there's more to the end-to-end workflow that you wanted to highlight here. We talked about some of the integrations and the visual displays, and we want to get rid of the reds, right? The reds aren't good. The greens are better here ultimately to assume a better risk posture. But Robert, I think there's more you wanted to highlight too in terms of how you use GitHub for some of these workflows.
Absolutely, yeah. So we covered most this side pretty well. I think we got all the way down to validation. I didn't really talk too much about InspecTools. I think I lightly touched on it. Basically, so at this level, once we've actually got a number, or sorry, not a number, but a JSON out of the validate and harden threshold, we actually need to go ahead and take that JSON and actually make sure it's either a pass fail, and then basically iterate on top of that. And so that's kind of where our InspecTools comes in. The 2 main ones that are useful for that is just our InspecTools compliance, our InspecTools summary. I've also got a lot of other tools that make it very easy to take the output of basically an XCCDF file that is provided with a STIG, right? That we can then convert to a shell inspect profile. So like for handling upgrades between versions, right? We don't really want to have to manually go through every time an update to a STIG comes out. We don't want to have to go through manually and figure out what exactly changed. We have a tool that'll just generate, a new clean inspect profile, and then we can kind of work the differences that way, for example. And so there's other things there that we do to kind of just automate as much of the process as possible around this whole infrastructure of building out validation content.
And Robert, we've converted both of these tools into GitHub Actions that you could use natively right out of GitHub, right?
Absolutely, yeah. If we actually have time at the end, I do have a full action that we'll take that I kind of wanted to walk through quickly building that will use our Heimdall tools and specifically our Heimdall tools action to go ahead and take the Serif file and go ahead and print it out as a JSON, and then I can load that JSON up into Heimdall. But I'll wait for your cue on that, Andrew.
You know what, Robert? You brought it up here. I'd love to see it. Love to see how you guys are leveraging GitHub Actions today, because I know you recently published your actions to GitHub Marketplace, your open source, so you've got all these integrations kind of ready to go for folks that are interested in kind of trying this out. But yeah, please do dig into the action you've developed. I'd love to see how kind of all this comes together.
Okay, very cool. All right, so what I have here is just a basic example repo that is only containing a Serif file at the moment. And that Serif file is obviously not an HDF, but luckily the Heimdall tools action, which I can easily Google.
And so sorry to interrupt, Robert. So the Serif file, right, for those that aren't familiar with the format, so that's the file that contains all the code vulnerabilities, right? So any static code analysis results.
Yep, and we also do this. We have a burp suite converter as well, which also has, and Sonar Cube, which both also do our other static code analysis formats that exist.
Awesome.
Standard Serif is the one that's actually a standard. I don't know if the burp suite and Sonar Cloud. I know those are just outputs of those programs.
Yep, Serif.
So I'm going to
formal standard with. Which organization body, Andrew? Oasis. Yeah, there we go.
Yep, Oasis.
Oasis standard.
There's a lot of ways you can represent vulnerability data. So between formal standards like from Oasis, or tool specific formats.
And that is one thing that staff is working. We're working with the director of open source at Oasis to actually make Heimdall data format and standard from Oasis.
Excellent.
And so I'm going to start here with just a real basic shell of a GitHub workflow, which is just the basic boilerplate name. I want it to run on my main branch, and I have one job I want to run, which is my convert job that runs on Ubuntu latest. The steps here are going to be, first up, we're going to need to clone the repository, right? So, and fetch step, we only need the latest. We don't need the whole repository history. So boilerplate is done. So now let's go ahead and actually use our action. So our action is called, we're going to just name this actual step, convert file to HDF, and it's going to use the MITRE Heimdall tools action version 1.1, which we actually released today, that adds in the Serif format. We just updated this today. So we had added Serif to Heimdall tools. We just hadn't updated our action until today.
So is the question mark intentional there too in the text? Heimdall tools. That's
me
right.
mistyping. That's me mistyping.
Oh, gotcha. Okay.
And so we're going to take in that Serif input.serif file that I had that is currently in the repository. Of course, if you just if that Serif file is generated from your code, right, you could pass it in a different way here. Whatever. In this case, it's just already in the repository, so this is all I need to do.
Gotcha. So if you enable code scanning like we have on public repos, the Serif file spits out. You can of course use that here.
Of course, yeah.
Awesome.
And then this is really it for actually creating the output. This will just generate the output at a file called Heimdall tools serif.json. Of course, it's not very useful if you can't actually get to it, right? So I'm going to go ahead and add one more step here that is just an artifact upload that goes ahead and uses the upload artifact action that I believe GitHub actually officially publishes.
Yep, that's an official action.
And only do it if the job passes.
And I'll catch you on another. I think I see another one there. I'm going to try to get it so we can run it successfully here. Looks like
all
user versus uses, line 20.
Yeah, I always do that one.
It's fine. It's all good. So where the collaboration comes in, right?
Right. There we go. So this actually very simple action, and this will take your file and just go ahead and give you out a Heimdall tools Serif that you can then read into HDF. So this is just going to be missing something on. I'm informed I'm missing something.
Look at
on
that.
convert.
An effective demonstration of paired programming. Robert C. Clark would be so proud right now.
Right. All right. Thank you, Kyle. And then I'm just going to go ahead and just commit this as create convert with HDF. That's fine.
Here we go. Fingers crossed.
All right, let's see what happens. Running. Cute.
Okay. Good start. Love it. Love it.
It means, I mean, that means it passed syntax validation, right?
Yep. Yep.
So that's a good start. All right.
And we're building. Okay.
Hopefully we don't run out of build minutes.
Huh. No, this is since we're in the open source, since all our stuff's open source, I don't actually think we're limited.
Yeah. So you are open source. You've got a unlimited number of build minutes that you can leverage, which is awesome. So it looks like I saw your action. There's some container logs flying through. So is your action a container-based action? It looks like.
Currently, it is, yes. So we are actually in the process. As of a couple days ago, we've just started the rewrite of Heimdall tools and InspecTools into JavaScript.
Awesome.
Once that's complete, then it should be quite easy to integrate this with. So I know all the new actions, the version 2 actions are all JavaScript, correct? So that'll make it much easier to actually write a native action. And so we'll start on that once we have the everything rewritten into JavaScript.
Awesome, love it.
So I'm going to go ahead and jump over here, and
so it looks like it ran successfully, which is great.
Yep.
So you're taking the file, the artifact file, and uploading it. Okay.
Yep, I'm uploading it to Heimdall, and you can see that the severity counts, status counts, all actually just dynamically updated. It's because this actually provides you a full overview of every file that you've loaded in. So let's say you have Seraph results. Let's say you have a Red Hat machine. Let's say you have an Nginx server running in front of your code. But right, if you have all that in one place, it'll this dashboard will show you everything as you load it up. So you can actually load everything about your environment and see one full picture right here. So that's just one of the features of Heimdall, but I'm going to go ahead and actually filter this down to just the Seraph results here. And we'll see, here's the different checks that specific Seraph file was running. And we can see basically all of them are fails, right? Because there's no such thing as a pass in Seraph format. If you have a problem with your code, it doesn't just mark every other line as a good line. It just shows you the bad lines, right? So when we convert it, we just include the bads. So you can see here basically the actual test, what line it's failing on, and the problem with that line, right? So this was based on one of the example files that's in our Heimdall tools repo. So I don't have the original source code for this, but this basically shows, on line 36, column 2 of one of those files, there's a lack of a check for a buffer overflow. So
it's like Heimdall inception. So you're taking your own code for Heimdall and scanning it and running it through Heimdall. So I love it. Love it.
And the other thing I want to point out here is, Robert, if you go down on the control, one of the data elements in the data table, you see how we've taken this CWE, right, Common Weakness Enumeration, which is another database that MITRE manages, and we've actually aligned it to those 853 controls. So we actually enriched the scan result data and added in those 853 controls. And one of the other things that I was thinking about actually doing was then making also these CWE identifiers linkable, so that you could then go click on that and go, well, what the heck is CWE 120 and why do I care? Right? Because the idea here really is, if you click on these PE numbers, right, you'll actually go to the NIST database and it'll tell you why, or what is PE, whatever, right? What is this thing? Why are you yelling at me? And why is it, how does it impact me, and all that kind of thing, to give context, right? Because then you could try to figure out what's my solution to this context,
Absolutely. And I know we've mentioned it a bunch of times, 853, for those that aren't aware, 853 is a standard from NIST, National Institute of Standards and Technology, akin to other standards organizations. And it's a collection of nearly 1,000 security controls that are systems and technology agnostic for best practices in terms of how you should configure operating systems and user authentication, and that catalog is used, not just by NIST and organizations within the U.S., but it's used by a lot of international standards bodies and organizations as well. So again, it goes back to regulatory compliance, for different systems. So awesome.
Yep.
So Rob, I think you were walking through something else as well. Sorry, we didn't mean to cut you off there.
No, that's mostly it. We've got basically we've managed to successfully use the Heimdall tools action here in about 5 or 10 minutes to convert this file, to create a full workflow that actually would convert this file over and generate an artifact every time. So if we were doing this in the real world, right, we would be just importing our artifact and just writing a quick workflow to convert it, and then we can just load it right up.
Awesome. And is Heimdall itself, so how does Heimdall itself run? Is it like on a web server? Is it in browser? How do you actually run the Heimdall UI?
Well, so the Heimdall UI is actually, it's a Vue application. So it's actually, there's two parts. There is a Heimdall server and a Heimdall Lite version. And they're actually, the way we've written it is, they're actually the same code base. The Heimdall Lite version is just the front end. Basically, the front end detects whether or not it has a server behind it, meaning if it actually has the back end behind it, right? And if it doesn't, then it just goes ahead and gives you a light mode. So that's actually what you see here. This is Heimdall Lite. And we have also a demo of Heimdall server we can go to, but that one actually requires a login. And it actually requires you to log in so that not everyone can just go and browse all of your results, right?
It looks like you even log in with GitHub. I like it. I like
correct. Yeah, we actually have GitHub OAuth set up as well. And so Heimdall itself is actually an open source application that we maintain. And we actually do a lot of stuff with GitHub Actions on that as well, basically to automate both our testing processes and our release processes.
Yeah, you want to click over and show them a couple of those actions?
Yeah, let's take a look.
Absolutely, yeah. So,
so we're really trying to eat our own dog food here, right? And,
for sure, yeah.
You know, we're the security guys, so we try to be exemplars in terms of, you know, keeping things up to snuff. And just as a note, all of our tools, everything that we produce, every example, every profile, it's all open source. Everybody in the world can use this, and you can adapt it to help meet your organizational requirements. Use our workflows just to help your projects get started and bootstrapped, right? We give it away. And the cooperation by the community has been huge, right? We have almost every major security vendor on the planet is one of our strategic partners, to include Microsoft and GitHub. You know, 30 to 40 different government agencies all across each of the spaces are all strategic partners. Everybody is contributing a little bit and getting a huge result back, right?
That's
and we'd love to have you guys join us.
That's awesome. And it's just, it looks like it's the Heimdall tool off the MITRE organization on GitHub. Excellent. And I was looking through the actions. You've got quite a few, which is really cool to see. And so you've got, I'm sure, some conditional branch policies and protection policies in place. Looks like UI tests and all sorts of good stuff. That's pretty awesome.
Yep, so we actually utilize a couple different things. So we actually run Cypress, which is a front end, or it's an end-to-end JavaScript testing framework. Basically, lets you actually click through your application for end-to-end tests. We also use Jest for back-end and front-end tests. We run CodeQL, of course. Previously ran LGTM before as well. We also use GitHub Pages to actually publish, since it's a Vue application, this is actually a GitHub Pages site.
Nice.
So we utilize that. We also use ESLint Prettier, Sonar Cloud. And then on top of that, when we actually go to do a release, well, so since we have a light and server mode on the application, we actually want to make sure that every PR that we get doesn't actually break our whole process, right? So we actually go ahead and in one of the actions, we run only the backend code, and in the other one, we run only the front end code. We'll actually delete the rest of the code completely out of our application to make sure that they are basically, we didn't actually introduce something that causes one of them to not build on its own, because that's important when we actually go to deploy this in a production environment. And then we also go ahead and do a couple other things that make it really easy for us to actually do a release. One of my favorite actions is actually the release drafter, because whenever we go to do a release,
I love that one too.
I have to, it's really great. All I have to do is go ahead and just click on the draft that it's written up, and I'm 90% of the way there already to a release. Our release process, there's a lot of steps that we actually need to do, but the steps that I actually have to do are very few. So we actually need to write up release notes. We need to push the new site to GitHub Pages. We need to push to NPM for our Heimdall Lite application. We need to push new Docker images, all of that. And really the actual process that I have to do each time we do a release is really 2 steps. It's bump the versions, which we have a tool we use Lerna for that's a managed JavaScript mono repos for you. So I just basically run learn a version. It automatically pushes up a new tag, and then I just click on releases, and I go ahead and just edit and publish, and we have a new release of Heimdall. Everything else, the push to NPM, is actually automated through our workflows. So yeah, we push to NPM with the, actually we just use NPM publish for that. I thought there was an action for that, but there actually isn't. Or at least we don't, we just use it, NPM publish, but that's the great thing about GitHub Actions, right? If you just have a command that you need to run and that does the job, you can also just do that. If there's an action that makes it easier, then that works too. And so also, one of my favorite things with JavaScript applications is, well, not one of my favorite things about JavaScript applications, but one of the things that is very prevalent with JavaScript applications is there's a lot of NPM packages and there's a lot of updates that we have to manage. As you probably noticed when I went to releases, each release we have, there's a lot of dependency updates. And we use Dependabot to make that a process a lot easier. So not only do we have Dependabot set up, but we also have it configured where if it passes CI and it passes all of our checks, since we have a lot of checks, we just go ahead and let that merge into master. And that basically makes the update burden on me and the developers very little. We can really focus on the code. We don't have to focus on there's a new version of whatever package, and if the update doesn't pass, right, then we go deal with that later. But most of the time, we found that most of the Dependabot updates just go ahead and run for us, and we don't really have to. We don't have to deal with the fact that there's a new version of Unify every week, or the fact that there's a new version of the AWS SDK every day, right? It's handled, and we move on working on the actual code.
Yeah. Dependabot is awesome. It's just such a great service, and it's kind of imperative for you all to take into account a lot of these Dependabot updates, since you yourselves are building a tool for conveying security information to others. So I think it's pretty incredible that you guys are using just the full gamut of the GitHub ecosystem to do all this. I noticed the discussions tab is open as well. Do you all have some discussions going on? So like, folks want to contribute into the community, but they're not necessarily willing to jump into the code or using discussions yet. It looks like a couple were open recently, or back in February.
Yeah,
So
we're starting.
I'm calling you out, Aaron.
Yeah, we're starting to work towards it. As of right now, we've still had people mainly just not realizing and still posting in our issues tab.
Gotcha.
When they kind of have a question, but I think as time goes on with discussions, we'll probably start just clicking. I think there's a migrate to discussion button, right? Yep. So
Yep.
as time goes on, we'll probably start just dumping those over when people do post those sort of things in our issues.
Yep.
Yeah, especially for those like higher level types of conversations, because working in the security space, you have a lot of individuals that aren't necessarily going to be writing GitHub Actions or Ruby code or getting it to this level. So having those types of individuals contribute discussions is really an awesome place for that. So it's great to hear that you guys are interested in leveraging that too.
Yeah, I like Graham Thorson's suggestion here for we need a tool for testing Heimdall. Yeah, so
Yeah.
We'll take that under advisement.
Love it. Love it. So we've got just a couple minutes left. Just want to let you all, or give you all an opportunity to kind of wrap things up here. And I think it's just a really awesome framework. And, something I want to point out, this is not the end all be all for the way you do security. This is just kind of one approach that MITRE you all have developed. It's a really cool and powerful approach. Obviously a security program has to take into account a lot of different, facets, not just hardening and technical pieces, but processes and business components to it. But I think it's something that a lot of organizations, a lot of groups just kind of overlook. They get right into the code, they start deploying stuff, and you end up in a potentially vulnerable situation. So I think it's really cool that you've all developed this, and the fact that it's a completely open source. It looks like saf.mitre.org is the website. I can go in, I can start contributing. Any other information about this that you all want to leave the folks with today before we wrap up?
Well, one of the things that I will notice is another example of how you can engage with the SAF ecosystem is what the Center for Medicare and Medicaid did in HHS. So you could go to saf.cms.gov, and you could see where they took all of our open source content and they tailored it for their organization. They even borrowed our website and used GitHub to publish their page. And
awesome.
They used all this. But if you look at their validation section, right, you'll see that they took all of our work and expanded it, right? They have a sub-selection of compliance requirements that they have to meet, and they're basically using those dependent profiles to say, well, if I want to do this for a high or a low or a moderate categorized system, right? How do I subselect and pare down all that stuff so I'm not testing stuff I don't need to test and all that? And, so this is a great example of how the community borrowed from the community, right? And didn't repeat itself, right? They kept it dry.
Yep, and a lot of these are actually written as overlays as well. These are inspec overlays, so it actually still utilizes the base code that we're using, and they're not having to just copy the whole repository in.
Yep.
That's really cool. So effectively, CMS and others, I imagine, they're just forking Heimdall and then really kind of extending that and implementing that, for their own requirements. And, they don't have to do a lot of the legwork. You all have done the legwork. The community's done the legwork to get them started. It's almost like a no-brainer. Like if I'm an organization and, working in the security space and I want to, kind of figure out the direction to go in, this is a great way to get started. So it's great to see.
And if you notice in our validation section, we're not the only contributors to the profiles and to the hardening and all that, right? Mindpoint Group has been helping us with hardening. Google has been submitting their own profiles for their PCI things. VMware has been submitting a lot of the Windows work because they have to do a lot more Windows. Tenable's even been pushing in, right? So, I mean, it's now becoming more of a, commercially, a lot of these guys are, they each have their own space, but from a higher level security perspective and as security practitioners, now they're having a place they can come together and work together and learn from each other. And I just think it's really cool.
Yeah, that's awesome. Well, really, again, really appreciate you both kind of joining us today. I'm going to hand it back to AJ in a second, but just security automation in general. A lot of folks are still trying to figure it out, and I think this is a great way for them to get started and figure out how they can apply, infrastructure as code, whether they're new to it or have a mature infrastructure as code strategy. I think this is just a phenomenal example. I want to thank you both and MITRE for kind of helping us today and sharing this knowledge out to the community. And again, it's open source as always, so you can go in, you can join the open source community at github.com/MITRE/the Heimdall, Heimdall tool. And contribute. So thank you so much. Really appreciate everyone's participation today, and I'll turn it back over to AJ.
Yeah. AJ, you seem to be muted.
Thanks for the heads up. Sorry about that, and thanks for pitching in right at the end. Thank you again, Aaron and Rob, for joining us today and really digging deep into this. And for the next demo days, we're going to take a little bit of a break. Just like last time, we won't be seeing you until about mid-July, but we are going to tackle another really cool topic, which you'll see on the end screen. So enjoy for a little bit, and I will see you in just a few weeks.